Yes, you're ready to go. Please, others, kindly mute yourself. If you have any questions, you may unmute and speak while speaker is okay. Okay. Yeah. Ram, it's your turn. Thank you.
Okay. Thanks again, Surinder, and welcome to everyone. Thanks for inviting me. Thanks to Jamal Muhammad College. As I said, I am from Trichy, and I'm very happy to be uh, talking to you today. So I'll be talking about astronomy for development, which is to say, how can a science like astronomy benefit society? How can it benefit people like you and me? There are so many fields of science. There are so many scientists working around the world in order to understand better our world, our universe. But we always have the question: how is that helping people? If I'm studying about black holes, if I'm studying about Jupiter, is there any use to the common man other than knowledge? So that is the question I will try to answer today. Sorry, just give me a second. So on the slide, you will see my name. There's also two other names, Kevin Govender and Ramasamy Venugopal, are my colleagues at the office here in Cape Town. We are funded by the government based in France. So those are the logos you see at the bottom. Okay, so my first question is why science? This is a question for people in the audience. So let me just yeah. Okay, so I think is the purpose of scientific research. Why do you think we should invest in science? Maybe you can just write on the in the chat. What is your opinion on this question? If anyone has any thoughts, why do you think we should study science? Why do you think we should spend money and time in scientific research? If anyone has answers, just please write them in the chat. Okay, I'll just give maybe a few more seconds.
Sir, hello, sir. Hello.
Any answers? Okay, I don't see any answers. Does anyone want to maybe say their answer on video instead of writing? Okay. If not, I will go to the next question, which is very similar. Why invest in astronomy? What is the purpose of astronomy research? Why study astronomy? What is your opinion? If anyone has again any answers, any opinions, please write them in the chat. There is no
ஆமாம் சார் நான் மியூட் பண்ணிட்டேன் சார்
correct
ஓகே
answer, wrong answer here. Everyone has
பண்ணிட்டேன் சார்
different
மியூட் பண்ணிட்டேன்
opinions, different perspectives on this issue. So if you have any answer, any response to the question, so if someone asks you why are you attending this training on astronomy, what would be your answer? What is the motivation for you to attend this training? Uh, does anyone want to say anything? Okay. If not, maybe I will just continue. Surinder, just let me know if there's any messages in the chat. I'm on full screen, so I can't see.
Yeah, sure, sure.
So,
If there is anything,
so
I can.
okay, thanks. Some of the common answers on why science, why astronomy. Number one, many scientists always say it is because of their curiosity. They want to understand how their world works, how the universe works. So that is a very valid answer, right? But sometimes the discoveries can also lead to path-breaking innovations in technology. This is not always planned. Actually, most of it is unplanned science breakthroughs. And these then lead to improvements in lives in society. So I just want to take a pause here and explain what I mean by improving lives and how do we define this improvement in lives. So the United Nations has come up with these common goals for the entire world called Sustainable Development Goals or SDGs that you may be aware of. So these are the goals that all the countries in the world should try to reach in order to improve society. So this is a list of 17 goals. They were agreed upon in 2015, and the aim is to try and reach these goals in 15 years. So from 2015 to 2030. We are now at the halfway point. Unfortunately, because of COVID, progress has been stopped on many of these goals. In fact, because of COVID, we have gone in the reverse direction on many of these goals. For example, goal number 1 is no poverty. So the aim is to reduce poverty all around the world. But you may be aware that most countries around the world, poverty has increased because of COVID. People have lost their jobs. The economy has gone down all around the world. In fact, it's estimated that just in India, there are 60 million people who have been pushed back into poverty, below the poverty line, which is about $2 a day, in the next 2 years. This is very bad news. Similarly, hunger has increased because of the pandemic, and it was already bad even before that. So, what is the role of sciences? What is the role of a field such as astronomy to solve all these basic challenges? If you don't have food to eat, if you don't have any prospects of a job, if you don't have money to survive, then why will you care about astronomy? What is the point of doing astronomy if there are so many other people who are struggling? So it's a very valid question. Anytime that, yeah.
There is a answer actually. Why conduct research in astronomy? Ram Physics has shared to protect our Earth from asteroids. So kind of answer is there, and people are asking if you can switch to presentation mode. There is no full screen actually.
Oh, okay. I thought I was on presentation mode.
We can see the presentation, but it's not in the presentation mode.
Okay. Hold on. Okay, how about now?
Just a minute. It's getting low.
Is it in presentation mode?
Just, we are not getting your screen. Maybe it's loading.
Now it's loading. Okay.
It is visible, sir, in presentation.
Okay. Okay. Yeah, thanks for letting me know. So I was saying, whenever satellites are launched, for example, or whenever a new telescope is built, people are always proud of the new scientific achievement, but there are also people who ask questions like, why should we spend money on satellites? You could have spent this money helping poor people. You could have spent this money on reducing hunger and things like that. It's public funds, funds from the taxpayer, from the people that is spent by the government. There is always these questions. You're spending our money something that helps people instead of astronomy. So this is not a new argument. It's been going on for a long time. Even when NASA sent people to the moon 60, 70 years ago, people asked, why must we go to the moon when we have so many problems here on Earth? And it's an argument that's still valid today. That I think so, because the sciences like astronomy and space, they have so much more to offer than just the satisfaction of curiosity. They can actually help us to reach some of these goals. So I'm not saying that astronomy is going to solve the problem of poverty. I'm not saying that astronomy will remove the issue of hunger in the world, but it can help a little bit in achieving some of these goals. So I will take you through some examples in this presentation. So one other thing that I want to bring your attention to is 2022 has been declared by the UN as the International Year of Basic Sciences for Sustainable Development. So you will be aware of the difference between the basic sciences and the applied sciences. So you have like very basic research sciences, astronomy, physics, then you have the applied side of applied physics, applied chemistry, and so on. So applied sciences, there's always a view that they are more directly connected to society because they are oriented towards solving the problems in society. But people always think the basic sciences or blue sky research sciences like astronomy have no connection with society, have no connection with everyday life. But this is not true. So this is what this year is trying to achieve. So this campaign that's going to be done in 2022 will highlight the links between basic sciences such as astronomy and the sustainable development goals in the previous slide that I showed. So you can go check the link. Again, if you have any comments on this concept, can basic sciences actually help people? If you have any opinions and thoughts, please put them in the chat. One example of how basic sciences are helping us is explained in this graphic. So COVID-19 has been the talk of the world for 2 years. And now we have vaccines, we have various other technological innovations helping us in our fight towards COVID. But remember, most of these innovations, most of this technology was developed because of basic science research that was done long time ago. So, for example, the very first year written in the slide, 1800. So, in that year, an astronomer discovered infrared radiation. Right? So, we use infrared thermometers to detect temperature, and it's been very commonly used during the COVID pandemic. But infrared radiation was made as a basic science discovery. When this discovery was made 200 years ago, nobody knew what the applications were going to be. So it was curiosity that made this astronomer study radiation and discover infrared radiation. Similarly, you see another one on cell phone technology. Everybody has a cell phone in the world these days. But electromagnetic waves, the theory, the foundation of electromagnetism was discovered by a scientist who was just curious. He was studying it. When electromagnetic radiation was discovered 150 years ago, nobody could imagine that we would have cell phones. Everyone in the world would have cell phones. Similarly, a lot of the vaccine-related breakthroughs, innovations, they came about as a result of basic research. So we would not have a vaccine if the world had not funded in all those basic research, many years ago. So this is the long-term benefit of basic sciences. You never know how your discovery is going to change the world in the future. Maybe not today, maybe not tomorrow, but maybe 100, 500 years later, your discovery might change the world. So that's one clear benefit of basic sciences. But there is also another benefit, a direct short-term benefit, which is what our office is trying to work towards. So that's what I will explain in the presentation. Before we get get into the examples, I just want to bring to attention a favorite quote of mine, which talks about, I think, the most important contribution of a science such as astronomy. So, astronomy as a field in which scientists study the stars, the galaxies, what's happening in the universe, the other planets, and so on. But more than that, I think what astronomy makes clear is that the human mind, that humans themselves are the biggest resource that we have. So imagine that we are studying what is going on at very, very large distances, light years, millions of light years away. We are able to study what is going on there, and we are able to say, this planet has this mass and it has this kind of weather, and it's so much distance away. This is really crazy if you think about it, because none of us have been able to visit this planet. Maybe we will never do. None of us have the possibility of going to another galaxy in person to see what's happening there. But we still know how the galaxy looks, and we still have a lot of information about the galaxy, even without ever stepping outside of our planet. And that is an amazing achievement of the human mind. So if we are able to achieve so much in terms of scientific innovations, then just imagine how much we could help in solving the problems of the world. So, the same mind that's used in scientific breakthroughs can also solve the problems here on Earth. And that's basically what this quote is saying. So, let me define astronomy for development. First of all, we say that it's the use of astronomy as a tool for sustainable development, as a tool to reach those sustainable development goals that I showed in the earlier slide. And astronomy here means the skills and methods of astronomy, the infrastructure of astronomy, such as telescopes and observatories, and also the people who practice astronomy, which includes the scientists, the astronomers, but also the astronomy communicators, astronomy outreach professionals, and so on. So, combined all these people, this astronomy community has many strengths that they can apply to solve issues in society. So this image shows the different aspects of astronomy that are very suitable for applying it to solve problems in the world. So one side is the technology and skill side. So because astronomy is such a high-tech field, it needs a lot of latest technology and very high-tech skills. Astronomy is also very interdisciplinary science. So you see all the blue bubbles there, those are the different scientific fields that astronomy closely works with. It works closely with physics, chemistry, biology, mathematics, and so on. So they're all involved in astronomy. And finally, astronomy is deeply connected to human culture. So whether it's India, China, or Mexico, all of our cultures have a history with the night sky. We all have stories about the night sky. All of our ancestors looked up at the sky and wondered what was going on there. So we have all these deep questions, is there life outside the universe, or what happened before the Big Bang? So these are questions that everyone around the world has, and these are not just scientific questions. These are also cultural questions as well, because it really speaks to who we are as human beings. So astronomy is deeply connected to our culture. You can't. I don't think there's any other science that is that has cultural significance. So, for example, if you take nanotechnology, there's no mythological stories about nanotechnology. There's no mythological stories about chemistry. Or maybe there is, but there's not as many as astronomy. So it's very deeply connected to what it means to be human. On the right, I've listed the website of our office. You can see some of our work there. So our office, as I told you, is owned by the International Astronomical Union, the IAU, and our office is called Office of Astronomy for Development. So it's the IAU OAD. You see the red location marker at the bottom of Africa in Cape Town, that's where we're located. We also have sister offices in Japan, in Germany and Norway, and then we have regional offices covering different parts of the world. Those are in the light brown. What we do at the OAD is that we fund projects all around the world. So we give small grants to projects around the world that can use astronomy to benefit society. So since 2012, we have funded about 200 projects to the tune of approximately 1 million euros. So you'll see some parts of the world are very busy, most of Africa, India, South Asia, and also South America and Central America. There's lots of projects in these areas. Okay, let's see if this works. Just a short video about our office.
There are a few things as mysterious and engaging as the night sky. The quest to understand the universe has driven human beings to push our minds and technologies to the absolute limits. Astronomy drives us to dream, to think, and to rise to unimaginable challenges. In so doing, to advance humanity's knowledge and ability.
People all over the world are fascinated by astronomy. Indeed, it is one of the few fields where researchers are complemented by a worldwide community of communication and outreach experts, enthusiasts, and amateurs. What we started was a way to use this reach astronomy and the large network of people to create tangible change in communities. In 2009, the International Astronomical Union, a global body of professional astronomers, developed a plan to better harness astronomy to tackle the many developmental challenges facing societies around the world. The result was the establishment of the dedicated Office of Astronomy for Development, or OAD, in 2011. Consisting initially of a small team located in Cape Town, South Africa, with a simple vision of astronomy for a better world. The OAD's task was to translate the strengths of astronomy into tools for solving challenges in society. Given the magnitude of the task, we went back to the community for answers. We asked people around the world for ideas on how they would apply astronomy, tools, methodologies, people, and infrastructure to further the United Nations Sustainable Development Goals. And we received a number of really innovative and creative solutions. This is funded by our overall, has supported 160 projects out of 100 countries, as well as established 11 regional offices in 90 centers around the world. Projects have used astronomy's tourism to stimulate livelihoods and promote Himalayan villages in India, tap into the inspiring potential of astronomy to promote peace, mutual understanding, and a sense of global citizenship in refugee camps in Algeria, equipped and motivated students in Rio de Janeiro's favelas in Brazil, and supported counseling efforts for internally displaced children in Nigeria.
All science, whether it's curiosity-driven or applied, has the potential to impact our lives. The OAD is just one small example of how even the most abstract of sciences can be applied within the service of humanity. There's, of course, a lot more to be done. The COVID-19 pandemic is stressing our social, economic, and natural systems. But we must remember there is possibly no greater resource on the planet than human life. If we're able to figure out what's going on millions of light years away, then surely we must remain optimistic that we can prevail over challenges here on Earth. Using astronomy as a stimulus, as a driver of the bigger picture perspective, the OAD sets out to harness the incredible power of the human mind to make the world a better place.
Yeah, so that's a very short video. I'm just going to take a pause here and ask if anyone has questions. Just trying to read the chat. If anyone has questions, please post them in the chat, or maybe you can let us know and let me know. If not, I will continue. So I just want to give. Someone trying to say something? Hello. I'll just give examples of what we mean by astronomy for development. So, just to take an overview, these are the Sustainable Development Goals, and it's hard to see how astronomy can help to reach these goals. One of the examples that we normally quote is using astronomy to stimulate economic development, such as in astrotourism. I will talk more about that in a moment. But also, astronomy can help to reduce inequalities by providing educational resources to people who are underserved and marginalized. It can also help to build capacity in certain fields such as programming and machine learning, and also further gender equality, and of course contribute to infrastructures such as observatories, telescopes, computer networks, and so on. Finally, we've also funded a few projects in art and media. So one thing to remember is that most of the people who are interested in astronomy, want to learn about astronomy, already, they have a prior interest in astronomy. So if, there's so much information available online on YouTube and other websites. There's so much free information available, and people always ask the question: there is so much information available. Why can't these students just learn from online resources, or why can't they just make use of these resources? But not everyone wants to learn about astronomy. Not everyone is interested in STEM. Not everyone is interested in mathematics. Some are even scared of mathematics. And for these people, they even students, they might not want to visit science centers and planetariums. But by using an artistic perspective, it will help to break down the barriers to reach those students. So a few of our projects have done exactly that. They have installed, they have made art installations combining science, astronomy and art, and sort of invited students to explore astronomy through the lens of art. So that made it more friendly to the students who might otherwise be scared by science, mathematics, astronomy, and so on. Okay, the first example, or the first category of project that I want to talk about is astrotourism projects. You might know the term astrotourism. It's tourism with a strong focus on astronomy. It's tourism that is driven by astronomy. It is tourism that is driven by the desire to see the night sky. Unfortunately, most of the world has high levels of light pollution these days. Most of us have not seen clear night skies in our cities. You have to maybe go to a rural area, to a mountain or a forest or somewhere else that's away from light pollution to see the clear night sky, the true beauty of the night sky. And therein is an opportunity for tourism. So all these people who want to experience nature, want to experience the true night sky, will travel to another place, and that place is usually a very rural or remote place. So then there's an opportunity to stimulate tourism in this location by using astronomy. So one of our projects, which actually started in India, did exactly this a few years ago. They work with people in northern India, in Ladakh. They trained a few of the villagers in Ladakh on very basic astronomy, just how to move a telescope, how to focus on an object in the sky. And then they help the villagers set up an astrotourism experience there. So the village is very close to Pangong Lake, which is a very famous tourist location in Ladakh. So the tourists who come to Pangong Lake usually go back home at night because there's not much else to do there. But because there's this new astrotourism experience, the tourists then came to the village. Otherwise, people just drive by the village. Nobody stops at the village. But all these tourists are coming there, they're stopping for an astrotourism experience, and some people are even staying the night at some of the homestays that have been built inside the homes of the villagers. So there is money flowing into the village from tourism because of astronomy. So this is one of the people that was trained through this project. The main thing to note about this project is that it is owned and operated by the village, by the community that lives there. So we give them training, we give them a telescope, and maybe help to set up the whole project, but it is eventually owned by the community. And the revenue that they generate from the astronomy experience, from the homestays, it is actually pumped back into the community in projects that benefit everyone. So two of the things they did during the COVID pandemic when there was no tourism is that they used the money from the project to build greenhouses and to refurbish a community center. So again, there's a very short video. Let's see which page.
हमारा 4 लेडी लोग और मैं हम लोगों को एक टेलीस्कोप ऑपरेट करने की ट्रेनिंग दिए थे 3 दिन का था वो। तो वहाँ पे हम लोग साइंटिस्ट लोग जो बेंगलोर से आए हुए तो वहाँ पे उन लोगों से मिलके उन लोगों से हम थोड़ा ज्ञान लें और टेलीस्कोप कैसे हैंडल करना है। इस गांव में काफी टूरिस्ट आता है तो टेलीस्कोप के जरिए हम उनको कुछ स्टार और कुछ प्लैनेट दिखा सकते हैं।
So these are some of the homestays that have been installed in the village. They're being trained on hospitality, how to prepare the food, how to present the food, how to talk to the guests. Because after all, it is a tourism business. So the astro stays, as we call them, combining astronomy, astrotourism, and homestays, has directly impacted on a lot of the sustainable development goals, the SDGs. So one is obviously reducing poverty because there's a new source of income for the people in the village.
Just a minute, I will.
It promotes sustainable tourism because these villages are powered by solar energy, and it promotes interaction between the local people living in rural areas and the travelers who mostly come from big cities areas. It also reduces gender inequality, promotes gender equality, because many of the women who run the astronomy experiences and the homes, many of the people who run the astronomy experiences are women who work. So it's usually the women who are based in the village. So there's lots of ways in which the projects such as this can impact the local community, can impact the SDGs. Just some numbers of the impacts in this year. So you'll see how much income is generated and how many travelers visited and so on. So because this location is in Ladakh, tourists can visit maybe 5 months in a year, because at other times there is no access. It is blocked by snow and ice, so there is no access. So just from 5-6 months, they're able to make this much. So now we're trying to expand this project to other parts of India and to other parts of the world. Okay, let me take another pause here. If anyone has questions on what I talked about, or if you have any inputs, please let me know. Or maybe just to get some idea from Surendra, do you know how many colleges, universities are represented here and where the people are from?
Ram, there are actually participants around India. Can you hear me?
Around India.
Yeah, around
Yeah,
India.
yeah.
So 100 plus participants are here. Also, some participants are listening from YouTube.
Okay. Yeah, just maybe just put in the chat what university or college you're from. That would be nice to know where you're from.
Yeah, participants, you may put your
Okay.
college institution name in the chat. That may be useful.
Yeah, thank you. So the next type of project through which astronomy can benefit society is something we call astronomy for humanity. This is my personal favorite category of project. So, astronomy is the study of everything outside of Earth. So, astronomers, scientists in astronomy, they're always looking outside, trying to figure out what is beyond Earth, trying to study that. But astronomy also provides a different view, because when you are looking outside of Earth, when you send satellites, you send spacecraft to study the universe, it is also possible to look back at Earth from space, and that gives a different view. So this image there in the slide, the little tiny dot that you see in the big cylindrical orange cylinder, that is Earth. So this is a picture that was taken by a spacecraft some 30 years ago, when it was really far away from Earth, and it just took a picture of Earth, and you can barely see Earth in that picture. So I think this was in 1990, so at the time there were, I think, 4-5 billion people on the planet. All of those billions of people, animals, plants, everything on Earth is contained in that tiny little pixel. Actually, technically, in this image, in the original image, that dot is less than 1 pixel in size. So you see, everything that we know, everybody we know, all of it is contained in less than 1 pixel. That really gives you, a different perspective of what is happening on Earth. So we are fighting over borders, we are fighting over land, we are fighting over religion, we are fighting over ideology, and all of this over that tiny little pixel. If you think about it, really, it doesn't make sense, because we are all in the same boat, like literally. We are all in this together. It doesn't make sense that we are fighting over everything, because our futures, our present is all tied together. So this universal perspective provided by astronomy is really strong. It proves that we are all really intimately connected. Like all life on Earth, everything on Earth is very tightly connected. We are all under one sky, so to say. And we have funded projects that have used this perspective provided by astronomy to stimulate tolerance, to build this idea idea of global citizenship. So I am an Indian citizen, but I am also a citizen of the world. I shouldn't have to limit myself to India or to Tamil Nadu or to Trichy. I mean, I can live anywhere. I can live in Trichy, but my views should be to benefit the world, right? Why should I only have to think about my own people when the definition that doesn't make sense anymore? When you say my people, maybe you're talking about your people in your religion, people in your family, people in your school, people from your caste. I think we should expand the definition to include everyone, because my people should mean everyone in the world. That is what this picture is representing. We are all so closely connected together. So there is even a project that some of my colleagues are working on that is using astronomy to reduce mental stress, which has increased a lot since the pandemic. The one project that we funded, the Astronomy for Peace project, was in Cyprus, which is a country in just between Europe and the Middle East. So Cyprus is actually an island nation that is divided between Greece and Turkey. So Greece claims one part of the country, Turkey claims another part of the island. So they are on the same little island, but then there are two countries. So the people cannot visit each other. There is a barrier between the two sides of the island. Because they have been they were at war many years ago, but now even in a post-war situation, they cannot exchange. There is no formal ties between the two sides of the island. As you can imagine, people on one side speak Greek, they have Greek culture, the people on the other side have Turkish culture, and many of the people don't like each other. Very similar to what's happening in India and our neighbors as well. We always view the other person as the enemy. And what this project did was, they brought children from the Greek side of the island and the Turkish side of the island, and they brought them together in the middle of the island, which is a buffer zone, a conflict-free zone, which is owned by the UN. And they talked to them about astronomy, about science, about this perspective of all of us living on one planet. The children initially did not talk much. Obviously, there was a language barrier, so they had to use translators between Greece and Turkish. But by the end of the day, by the end of the activities, the children really realized that they were all connected together, that they had more in common because they come from the same part of the world even. They're living on the same island. So everything other than their nationality and maybe their culture, they share. Everything else is the same for them. So imagine if we can bring together children this way. Maybe someday we can even bring together politicians and people on ideological opposition, people in political opposition. So this kind of project directly influences the SDG on peace and justice. I think I have another video. I won't play the full video, it's a long one. I'll play just one part of the video.
I remember when I was at school.
Oh, sorry.
And I used to wait for the bus to go to school. I could see the mountains in the north, the Bedachtilos or the Bedachtilos mountains. And at that point, obviously, there was tensions and you couldn't go there. And the only thing I knew about these mountains were the stories that my mum had told me, always wondering what it was like on the other side of the island. I imagine that there were also people in the north who would look to the south and wonder what it was like there, like I did when I was a child. When I found out about this project, Astronomy for Peace, it suddenly seemed like such an ideal time to get the two children from both sides of the island to meet each other. It's to dispel this myth of them and us.
The Mobile is a science education project that has a goal to share astronomy with young people around the world. We wanted to use astronomy to bring together the world's communities in Cyprus and to use the sky as something that they both share.
Columba is a constellation, and it's the dove constellation, which is a well-known symbol of peace. So we thought it would be nice to have this as the name of our project. The primary goal of the project is to promote meaningful communication between children and adults of the two communities living in Cyprus, and also to promote the feeling of global citizenship, in which we focus on our similarities rather than our differences.
I think this project is extremely important in Cyprus at the specific moment in time, since even though the checkpoints on the island have been open since 2003, the separation has been way longer. We have been separated for more than 50 years, and this requires the contact between the two communities if we are to live together.
Is that the children learn through inquiry and through hands-on activities about astronomy and about the universe, by asking questions and trying to find the answers together. Okay, so what I want us to do today is to make our own golden record from Cyprus. Okay, what we would want to send to an alien civilization that would be representative of all of Cyprus. Okay, this is a very nice activity. It's based on the golden record that's on the Voyager spacecraft, which were launched in the 70s. Well, it was more symbolic than anything. It was if these spacecrafts were to ever be intercepted by an alien civilization, for us to give kind of a token of Earth. So, for example, images of people, images of natural landscapes, animals, sounds of Cyprus, which could include nature, sounds of nature, sounds of animals, music, different musics from the island, our languages, different languages that are spoken on our island, food of Cyprus, and I want to know if you have any other ideas or topics that you think would be important. This is really great because it gives the children an opportunity to discuss about different things that they want to send that is representative of all of Cyprus, that are actually similar between the different communities in Cyprus, but also the differences, which are very interesting. And so, yeah, so the idea is to build a golden record from Cyprus as a representation of our country, of our common land. What's your favorite food?
So let me just stop there. But basically, they're trying to get the children to work together to build a common idea of Cyprus. One other project that I like in this category of Astronomy for Humanity is supporting people living in camps for refugees, camps for displaced persons. This project called Amanar was funded by the OED a few times. It takes place in the refugee camps in Algeria. And what the astronomers did, or what the project did, was they visited the camps and then they trained the teachers in the camps on hands-on astronomy activities, which would be good at improving the interest of students in STEM, even in just learning. So you can imagine that in refugee camps, the educational infrastructure is not of high quality. They are very severely under-resourced. So this kind of project elevated the education at the camps. It brought children an opportunity to look into STEM and everything else that brings. Okay, let me again stop here to see if anyone has questions. I'm just reading a chat. Okay, yeah, I see people from several states, many universities. Okay, I don't see any questions. I will continue on to this last category of projects, which is using astronomy to build capacity. So we always say at our office, our objective is not to train people just in astronomy. That is good, but that is not our aim. There are other people doing it. So our aim is to use astronomy to train students or to train people in other fields. So, for example, we have supported projects that organize programming workshops that used astronomy context, that did mathematics and learning workshops using astronomy context, uh, data science and machine learning using astronomy context, and so on. So the point here is that astronomy provides a very fascinating background against which to develop your activities. For example, one of our coding workshops in South Africa actually created this Mars mission. That was their context. So the kids had to work in groups to send a spacecraft to Mars, and as part of that mission, they had to build a robot. They had to program the robot, and they had to program a rover. They had to build certain other things and so on. So the context here is astronomy and space, which really attracts children, which fascinates children, and it gets them curious and gets them to start learning and exploring. So that's what these projects do. They use astronomy to develop capacity in other fields of learning. But learning and teaching astronomy is also important because many of the skills in astronomy are very critical for our future, even in the present, such as machine learning and AI, which is really exploding, data science and so on, which is so integral to astronomy. But anyone learning that can also get a job in some other field. Astrolab is one of the projects that we funded under this category. Astrolab is a project that teaches students at universities that do not have the funding or the infrastructure to buy their own telescopes. So there are many universities around the world, even in India, that don't have astronomy programs because they think, oh, we need money to buy a telescope, but you don't need to buy a telescope to start an astronomy program at school or university. So what this project did is they used remote telescopes. So these are telescopes that you can access through the internet for a small fee. So usually it is a few dollars an hour, a few dollars a session. So the telescope will be located in a very good dark sky location, like some island or some desert area, and it will be connected to the internet. So you can just pay for some time on the telescope. It will be a very high quality, research quality telescope. You just pay for the time, and then you observe the sky, you download the images, and you basically do your analysis. So this project used such kind of remote telescopes to teach students at universities which could not buy the telescope. So in this way, the student learned the process of research while not needing to buy expensive astronomy infrastructure. We are also funding a series of hackathons, big data hackathons around Africa. Again, these hackathons use astronomy-based context while teaching big data related skills to the university students. Okay, let me end there, and I am open for questions. I see what we have less than 10 minutes left. Are there any questions? Are there any points that you want to bring up, anything you want to discuss?
Yeah, participants, the floor is open for questions or discussions.
Sir, how can someone register to the Astrolab?
Yeah, Astrolab. So just drop me a mail if you are interested in Astrolab. Currently, most of the universities participating in the program are based in Africa, but I can put you in touch with the coordinator if you have any specific ideas. I will. Yeah, let me drop. Suren, where can I drop my email? Should I just put it in the chat?
Yeah, you can put it in the chat, or we can send our email to them. So we are sending few resources to them. I can attach your email also.
Yeah, maybe, yeah, okay. Yeah, because in the chat it might just get lost. But let me go on there. Any other questions?
Sir, one of the participants asked questions in the chat box. The question is, what is the role of nanotechnology in space science?
What's the role of nanotechnology? Well, in the world of space, now everything is in miniature. So you know that satellites used to be really big 40, 50 years ago, but now we are able to develop and send CubeSats to space, which are just 10 centimeter in size. And these can pretty much do the same job as a big satellite from the 70s. So a lot of it is down to electronic, the development in electronics. Nanotechnology specifically, I'm not aware, but there are lots of projects in the US and Europe which are trying to build on such applications. How does mechanics work in space? When you say mechanics, do you mean like motion? No, it would not be the same as on Earth. Yeah, so motion, yeah, I mean, the laws of motion apply, but obviously there's microgravity, which is to say, so in space there is gravity, but it's really small. So it makes everything complex. You know, even the act of eating or moving in space, you would have seen videos of astronauts floating in the space station, and when the astronauts want to eat, they can't just grab food because they're in a microgravity environment. Everything has to be done precisely. I would encourage you to just search on YouTube, you know, astronauts space station, something like that. You will find lots of videos.
Any more questions?
If there is no more question, we may come to the closure of the meeting.
Yeah, I just want to say thanks again and Jamal Muhammad College. Thanks for inviting me, and I hope it was useful. Thanks to the participants.
Dear participants, we come to the end of this two-day faculty development program. It is a time for formal vote of thanks. I request Dr. S. Abbas Mandri, Assistant Professor of our department, to propose a vote of thanks.
Good afternoon to one and all. It is privilege to me to propose a vote of thanks on behalf of Department of Physics. First of all, I thank to Almighty for the successful completion of the two-day online faculty program on astronomical studies. I would like to thank our Honorable Secretary and Correspondent, revered Secretary, respected Treasurer, revered Assistant Secretary, for their constant support to our department for the successful completion of the program. Next, I would like to thank Principal, Vice Principal, Additional Vice Principal for their constant support to our department. Next, I would like to thank Honorary Member and the Director of Hostel Administrations for their support. Next, I would like to thank our resource persons for the successful completion of the online faculty development program on astronomical studies, successfully completed by and conducted by the PG Research Department of Physics and the IKSC cell of our college in collaboration with the Siguru Collab. First, I would like to thank the resource person, Dr. Venkateswaran, who spoke on recent development in astronomical studies, higher education perspective, on 7/2/2022. Next, I would like to thank Dr. Priya Hasan, who spoke on career pathways in astronomical education and research. She gives on some fundamental ideas about the astronomical education in research area. Thank you, ma'am. Next, I would like to thank today the resource persons, Dr. T.B. Dinesh, who spoke on decentralizing astronomical education. Next, I would like to thank Mr. Ramasamy, who gives on astronomical data and technology. I would like to thank the resource person Ramasamy Venugopal, who spoke on astronomy for development in simple manner. Totally 5 resource persons were arranged by our Department of Physics under a DPT Star College scheme, who spoke about some fundamental ideas about astronomical development in research area. The 2-day faculty program will be benefit to all our faculty members. Around 500 faculty members in and around the India who participated in our 2-day FDP program. I would like to thank all the resource person who gives an effectively and encouragement to the young scientists to like our young generation faculty members. Thank you, sirs. Next, I would like to thank our head of the department who gives an constant support to our department. Next, I would like to thank our department DPT Star College Scheme Coordinator Dr. A. Ishaq Ahmed and DPT Star College Scheme Assistant Department Coordinator Dr. Sheikh Dawood, who gives some valuable innovation ideas about the DPT Star College Scheme in our department in an effective manner. Thank you, sirs. Next, I would like to thank all the faculty members who gives a constant support to our department. Next, I would like to thank our lab assistants and the technical assistants for their constant support. Thank you, Nanda.
Yeah, thank you, Ram. So thank you very much for your wonderful session.
Thanks, everyone.
Dear participants, you will receive your e-certificate within a week through your registered mail ID.
Mr. Surendran, and through him Mr. Ramasamy of Chiguru Lab for coordinating with us, helping us in organizing this FDP program and making this a grand success. So once again, on behalf of PG and Research Department of Physics, I thank both these persons from Chiguru Lab for having entered into a memorandum of understanding with our department and encouraging us in all our activities. Thank you.
Thank you, sir. Thank you.